Hello, welcome to Mechanical Systems 2. So again, the goal here is to take a mechanical system and write the governing equation, or equations in this case, for its motion. So here we have two masses. Oops, forgot to label my masses, M1, M2. This is a problem that is deliberately designed to force us to be really cautious about how we deal with free body diagrams, with signs, and oh, look, how we label our individual components. So I'm going to show you some tricks, hopefully, for keeping good track of how you keep track of your signs. Okay, so in this case, we've got a base that can move from side to side, and we have some masses that are on rollers on top of it. So these masses can slide side to side. You could imagine scenarios where maybe in the bottom of a cargo ship you've got masses that are free to slide, but there's some friction and maybe some nylon straps with finite stiffness that attach them, and you want to see how they respond as things move around, right? So there's one scenario where something like this might arise, right? You can imagine all sorts of permutations. All right, so here we go. So let's start with the free body diagram, as always. I'll start with mass 1 up here. A very good place to start. Careful to, as always, notate my coordinate system like that. Now there are 1, 2, 3, 4 components acting on mass 1. So I will have 1, 2, 3, 4 forces. Now I've drawn those forces with directions that I just picked out of my head. Now I've just chosen to always have them acting into the mass, right? That's the convention I've chosen because it appealed to me. All right, now I'm going to be really careful in how I label them, right? So every component now has a unique index, right? So this is B1, B2, B3, K1. So I might as well give the forces the same name. It'll make it easier for me to know which one's doing what. So here's K1, and here's B3. Okay, there we go. So now I'm going to go ahead and write my mass equation off to the side here. mx1 double dot is equal to some of my forces. Okay, well, good thing I have my coordinate system here so I know which way is positive. So I've got fk1 plus fb3 minus fb1 minus fb2. Okay, I'm done. That's my mass 1. Moving on, I'm ready to look at my mass 2. Okay. I am being very careful to note my coordinate system. Check it out. They're moving in opposite directions. So, I mean, this is ripe for error, right? We need to be very careful. Also, I've got two components shared here between mass 1 and mass 2. That means I need to be really careful about my direction. So they're moving to the right here. Right? So I need them moving to the left here. There we go. And I've got a third component over here from K2, or force over here from component K2, that, yeah, I can draw it any way that pleases me. I'll continue to just draw all the forces pointing into my masses. Okay, now I'm ready to write mx2 double dot is equal to, well, clearly K2 is wait, no it's not. This is why I was really careful to draw my coordinate system. Yeah, fk2 is negative. My positive forces here, check it out, are fk1 plus fp3 minus fk2. There we go. All right. Now, I'm going to work my way through the components just as carefully as I did through the masses. So in the components here, I'm going to start with B1 and B2. They're right next to each other. Wow, this is the first time we've seen two identical components side by side. Normally I don't bother to do that. As we're going to see, they really just add. two dampers side by side, as we're going to see, are it's equivalent to one damper with that sum of the damping coefficient. All right, now you might be tempted to draw these dampers on the right-hand side. Check it out. At this point right here, this point is not tied to ground, like you might be tempted to draw it as. This point right here is tied to y. So if you move y positive, this point moves with y. Absolutely. So the coordinate system I need here is y. Same thing with x1. Oh, excuse me. Whoops. Got ahead of myself there. Yep, that's x1. There we go. All right, so the forces on mass 1 here. Forces on mass 1 here. So these forces are going to be pointing inward. And this is going to be FB1. This is going to be FB2. Good. All right. Well, clearly it's going to be B1 times something and B2 times something. So the question is which one is positive, right? So B1 and X1 are pointing in the same direction. B1 and Y are in opposite directions. So we can say it's going to be this minus Y. So X1 is positive because force B1 agrees with X1. Force B1 opposes Y. So yeah, there we go. Of course, hopefully all of you were shouting at your computer screen, you forgot your dots. Don't forget your dots. Don't forget your dots. Check it out. This is going to be identical down here. Don't even have to think about it. They're identical. Everything's the same. So yeah. There we go. Because these two forces are acting in parallel, wherever they appear, they'll just combine, right? So right here where they appear, they'll just combine. So basically B1 and B2 will just combine when we're done algebraically. Isn't that handy? Okay, so we've got B1 and B2. Let's look at K1 and B3. They're side by side as well. All right, so here's K1 and B3. This is the first one where we really want to be careful here. K1 and B3 are tied to components that have opposing coordinate systems. So K1 on the right-hand side is tied to X1, and it's pointing to the right. And on the left, it's tied to X2. It's pointing to the left, so we'll do this. Okay. All right. The forces involved. So FK1 and FB3, we need to be consistent with those. So at mass 1 connects right here. Mass 1, the force is pointing to the right, so here they're going to be pointing to the left. Well, then the forces must be doing this. Are those consistent with, oops, sorry, I got in my field of view here. Now, are these consistent with what I have here? Because I have K1 here. Let's just say at this point of contact, we're here. Yeah, sure enough. K1's pointing to the left here. It's pointing to the right here. Absolutely. It's pointing to the left here. It's pointing to the right here. Yeah, we're okay. Everything's okay. All right, so FK1 is equal to K1 times something. B, we'll just turn that into a B. Pretend I didn't make that mistake. B3 is equal to B3 times, there we go. Oh, whoops, and I did forget to note. Yeah, there we go. All right, so, well, shoot. Everything's going to be negative. My forces are opposing both of their coordinates. Negative x2, negative x1, negative x2, negative x1. Those of you playing along at home should be shouting at the computer at the top of your lungs so everyone in your house can hear it. Absolutely. No one will think you're crazy. We need your dots. Don't forget your dots. Okay. Okay. There we go. We only have one component left, but I'm out of page, so here we go. Let's move on. Now I just need to look at K2. On the left-hand side of K2, we're attached to Y. On the right-hand side of K2, we are attached to X2. Fun. Forces. K2. I have written that one before. Ah, there it is. Right there. So at this point of contact right here, or here, the force here is moving to the right, so the force here had better be moving to the left. There we go. We're ready to write the equation. Alright, so K2, let's see, is, oh my, everything's positive. Look at that. The coordinate systems are agreeing with the forces on everywhere. So it's going to be x2 plus y. Weird. Alright, so we've got all of our free body diagrams sorted out. Now I'm going to show you a little, I'm going to do some magic, and I'll show you how I did it in a minute. But allow me to just aside, now that we've done all our free body diagrams, we'll come back to that in a minute. We still need to plug in and substitute and do everything all at once. Let me just make a quick prediction of what the answer is going to be. I bet, if I wave my hand and look into a crystal ball or some nonsense like that, so m2 x2 double dot plus, I predict it will be this. I predict that, and I predict, this. I predict that will be the answer for K2. Now I can do this, well, sure, why not? Why not? I'll go ahead and make a similar prediction for X1. Why not? Because I can. Now this is going to be interesting. This is certainly not because I've seen a ton of systems that look like this before. Absolutely not. This is a little unusual. So there we go. And now let's start with y. So that's going to be plus. Alright, those are my predictions for what the answer will be. Now I did that just by glancing at the system. We're going to use that same approach to check our diligent work, right? So I'll show you how I did that in a minute. Now let's put this aside. So I did that just to prove to you I can do this ahead of time, right? Just to prove I'm not cheating. Now let's resume our work. We'll come back. Alright. So first, let's start with mass 1. Here's our equation for mass 1. Alright, now we need FK1. Now I'm going to be very diligent about moving through the components. Where is FK1? FK1 is right here. Everything is negative. Negative K1, X2, negative K1, X1. Okay. Now FB3, where is FB3? Down here. Again, everything is negative. Negative B3 X2 dot. Negative B3 X1 dot. Okay, so that's B3. Now, B1, I need to take the negatives, because it appears negative here, I need to take the negative of everything I see with force B1. So that's going to be negative B1 X1 dot, positive B1 Y dot. Good. And now, finally, FB2, right here. So I'm out of space, so I'm just going to move to the next line. Sorry, running out of line there. There we go. Negative b2 x2 dot positive b2 y dot. Okay. Not bad. That's my equation for x1. Why don't I go ahead and group it so that all the x1s are on the same side. Once we do that, we can actually start to check to see if we believe our answer or not. All right, so let's do that. M x1 double dot. Let's see. So it's x1 double dot. Now let's group up all the x1 dots. I see 1, 2. Only 2. Oh, it's because I made a mistake here. That shouldn't be x2. That should be x1. Oops. Yeah. Yeah, right here. Copied the wrong one. Oopsies. There we go. 1, 2, 3. Yeah, so do. There's that. All right, and now all the x1s, so that's the only one I see, plus k1, x1. You'll notice they're positive now because I'm moving them to the left-hand side of the equation over here, way over here with the mass. All right, all that is equal to, now on the right-hand side, we'll have, all right, what's left? Let's start with the x2, well, we'll start with the y's since that's the order I did it in before. It looks like the only place where there are y's, it's all attached to b1 plus b2 y dot plus, all right, now the x2 dots, there's this, so we've taken care of these. Now here we've got a negative b3 x2 dot negative k1 x2. There we go. How did we do? I wonder how that prediction went. So here, let's get them all next to each other. So my mx1. Oh, look, I nailed the b's, nailed the k1, nailed the y dot, and yep, nailed the x2s. They were both negative. All right, how did I do that? Well, check it out. I'm going to compare this result with what I see when I look at M1. So apart from the mass, right, what components affect M1? The answer is there are 3 dampers that affect M1 and 1 stiffness. So, and they all have to be positive. They can't be negative. None of these produce negative damping. So when you move them all to the left-hand side, all of these dampers need to show up as positive, all the springs need to show up as positive, all working together to keep M1 right where it is, right? So, dampers all add, and there's a stiffness there, right? So basically, just by glancing at it, I can figure out what the left-hand side of the equation is going to be. Done. Now the only thing that's left is, okay, which other coordinate systems, which external forcing is going to now affect x1? No, again, those come, in this case, they're going to come through the components. So, if I look y, how will y affect x1? Well, only through 2 components, b1 and b2. And they're moving in the same direction, so the sign is going to be positive. b1, b2, positive. All right, how is x2 going to impact x1? Through k1 and through b3. Their coordinate systems are opposing, so the signs will be negative. So k1 and b3, and their signs are opposing. We're done. You can use this trick to quickly figure out if you've made any mistakes. If you don't trust yourself with the trick, though, of course, you want to work through this, but you can then quickly go back and check to make sure everything looks right. All right, let's do that again with mass 2. m2x double dot x2 double dot is equal to, all right, we only have 3 forces here. This should be way easier. So K1, let's see, or excuse me, yeah, K1, yep, we need K1, that's right here. Everything's negative, so we'll have negative K1 x2, negative K1 x1. Good. All right. Then we need positive, or excuse me, where am I? Yeah, here we go. Positive B3. That's right here, way at the bottom here. Yep. So everything's still negative. Negative B3 x2 dot, negative B3 x1 dot. Okay. And now one more term. We need negative FK2. FK2 is way over here. Everything's positive, so, but remember, we're going to make it negative. So we have to take the negative of everything. So we'll have negative FK2 x2, negative K2 y. There. All right, again, I'm going to group everything just so I can apply this little method to check it. And then just look over my own shoulder and make sure I'm doing everything right. All right, if I group up all, this is, the mass I'm looking at is x2, right? So I'm going to group up all of the x2s. Here's x2, here's an x2. All right, yeah, it looks like there are only 2 of them. Oh, sorry, silly me, 3 of them, of course. Yeah, there are 3 of them, as there should be. B2 x2 dot plus K1 plus K2 x2. If I group that all on the left-hand side, that's what I will get. And then on the right-hand side, we've taken care of those 3. On the right-hand side, then we will have a negative K1 x1, a negative, that's taken care of, B3 x1 dot, and minus K2 y. Okay, we're done. All right, before we look at what I predicted it would be, let's do our quick check and see if that makes sense. Mass 2. Okay, so what are the components that affect mass 2? There's B2, or excuse me, B3. That should be B3. It was sloppy. Yeah, and yeah, it's B3. I just wrote it wrong. There's B3. There's K1, and there's K2. And the 2 stiffnesses are going to work together to hold x2 right where it is. That's correct. All right, now which external coordinate systems are going to impact mass 2? There's going to be y and x1 are all connected to x2 through components. So y is connected through K2. And because their coordinate systems are opposing, I expect the sign to be negative. I expect there to be a negative K2y on the right-hand side. There is. Good. Okay, I can do the same thing here. x2 and x1 are affecting each other through K1 and B3, but their coordinate systems are opposing, so I expect there to be a negative K1 x1 and a negative B3 x1 dot on the right-hand side. Negative K1 x1, negative B3 x1 dot. How does that compare? Oops. Not at all with that page. There we are. How does that compare with my predictions? Let's see. This is for x2. So on the left-hand side, looks pretty good. And on the right-hand side, we've got a negative K2y, negative K2y, B3 x1 dot, B3 x1 dot, K1 x1, K1 x1. Yep. There we go. All right. I hope that was helpful. So that was relatively tricky. Go ahead and send out your questions, and I'll do my best to reply to them quickly. All right, take care.